Why, hello. We're here to talk today about assignment 33A. And this is a day I've slid in to give us some more practice with limit definitions of the derivative before we start reviewing for the test. So, without further ado, how about some bell work? Write the three limit definitions of the derivative without looking at your notes. Because really, you need to have this stuff in your head. And if you don't have it in your head yet, you're behind, and that's not a good sign. Okay, so do this and then come back. Welcome back. So f prime of x, the general derivative, is the limit as h heads to 0 of f of x plus h minus f of x all over h. But if we just want to know the derivative at a point x equals a, then we can say the limit as h approaches 0 of f of a, that specific place we want to know the derivative, plus h minus f of a all over h. And finally, we have a second derivative at a point, limit as x heads to a of f of x minus f of a all over x minus a. Okay, those are our three limit definitions of the derivative. I hope you are comfortable with them. Next, given position s of t equals 1 over t, where t is in seconds and s is in feet. Okay, so that's our precondition. That's the stem of the problem. Now R is part A. Find the average velocity on 1 to 4. Okay, do that one. So average velocity, we remember, is the slope of the secant on with the 2 points on the interval. So we need s of 4 minus s of 1 over 4 minus 1. That's going to be average velocity. And notice to find average velocity, these aren't velocities, these are positions. Velocity is defined as the rate of change in position over time. So we are thinking then about finding the slope on position between these 2 points. So s of 4, I plug a 4 in there, I get 1/4. S of 1, I plug a 1 in there, I get 1. 4 minus 1 is 3. Now, I have to make a common denominator over here. So now I'm going to have 1 minus 4 over 4 over 3, which is negative 3 over 4 over 3 over 1. And when I do the flip and multiply, I end up with negative 1/4. And don't forget units. So we know that s is feet. These numbers on top, these s values, these are feet. So I have feet on top. And what do I have on the bottom? Time in seconds. So negative 1/4 foot per second is my answer for part A, the average velocity. But what if instead of average velocity, we're looking for instantaneous velocity at t equals 4. Okay, so, we can use our limit definition of the derivative to find the slope on position at a point, which is the same as velocity at a point. So how about we use f prime, oh no, s prime of 4 equals v of 4, which is the limit as t approaches 4 of f of t minus f of 4 over t minus 4. So that velocity then is going to be f of t, which is, oops, don't forget the limit. The limit as t hits to 4. At f of t, I guess I'm saying velocity, so I'm going to make these s's for consistency. There's s of t. 1 over t minus s of 4 would be 1 over 4 over t minus 4. So here I need to make a common denominator. The limit as t heads to 4 of 4 minus t over 4t over t minus 4 over 1. So we need to do the flip and multiply there. We're going to have the limit as t heads to 4 of 4 minus t over 4t times 1 over t minus 4. Now these are opposites. I have a negative in front of the t, I have a positive in front of the t. I have a positive in front of the 4, I have a negative in front of the 4. So if I pull a negative out of the top, that's going to give me negative 4 plus t, and then I can cancel these. So, because I'm running out of space here, I'm going to erase a bunch of this stuff and say, I know that v of 4 is negative 1 over 4t. No, it isn't. It's negative 1 over 4. It's the limit. That's what's missing. The limit as t heads to 4 of negative 1 over 4t. And now I can do my direct substitution and get negative 1 over 16. So velocity at time equals 4 is negative 1 over 16, and the units feet per second. And we can see that the velocity at the end of the interval was much lower than the velocity, the average velocity on the interval from 1 to 4. Okay, so let's move on. We're going to work with the same s of t here, 1 over t. And these are still seconds, and these are still feet. Okay, so we just did, we did instantaneous velocity one way. How about again, a different way? S prime of t is going to be the limit as h heads to 0 of 1 over t plus h minus 1 over t all over h. So then when I make that common denominator on the top, t minus t plus h over t plus h over h over 1, I can do the flip and multiply there. Now what? Oh, see that minus? It has to be distributed to both of these. And the reason I put parentheses here was to remind me that, because when I made the common denominator, t plus h, a lot of students forget to distribute that. And so those parentheses really reinforce for my brain that I need to be distributing the t. So t minus t, those cancel, and I have minus h over h, those cancel, and so I'm left with the limit as h heads to 0 of negative 1 over t plus h. And it's at this point I'm able to get to do the direct substitution for this limit and not get 0 over 0. So when I plug a 0 in here, I get negative 1 over t squared. This is s prime of t, or v of t. And what do I want? I want to know v of 4. I want to know the velocity at 4. So I'm going to plug in this here for time. Negative 1 over 4 squared, or negative 1 over 16. So we've used 2 of the 3 limit definitions of the derivative on this problem. I'll let you do the third one if you want. Hopefully I showed one of yours. Okay, next we need to find the equation of the tangent to s of t at t equals 4. So what information do I need in order to write the equation of a tangent line? Well, we need a point, and we know half of that point is 4, but I also need to know s of 4. And what else do I need? I need a slope. And we know in this problem that slope is s prime of 4, or v of 4. I need a slope at a point, and I need a point. To find s of 4, I'm going to plug a 4. Remember, our s was 1 over t. So I'm going to plug this 4 in there and get 1/4. So now I've got everything I need to write the equation of the tangent line. I have the slope, I have the point, and I can just write y minus 1/4 equals, what was the slope at 4? What was velocity at 4? It was negative 1 over 16. Negative 1 over 16, t minus 4. And really, I'd stop here. I really would. If you simplify further, though, I believe you end up with plus 1. Okay. Next question. D. Find the equation of the normal to s of t at t equals 4. Well, the normal runs perpendicular to the tangent. So it's the equation of a line. I need a point at time equal to 4. I remember when I plugged 4 into s of t, I got 1 over 4. So that's my point of tangency, where the normal is perpendicular to the tangent curve. But I also need v of 4. I need the slope of position at 4. And we said that was negative 1 over 16. But wait a second. Isn't the normal perpendicular to the tangent line? So my slope, my perpendicular slope, will be what? If the slope of the tangent line, the slope of the curve is negative 1 over 16, what must be true about the slope of the line perpendicular to the tangent line or to the curve? And so that's going to be opposite reciprocal, or 16. So now my normal line is this. And again, if you really want, you can tidy this up, but I wouldn't. Minus 63 and 3/4. That's going to be negative. That's going to be plus when we move it over. Okay. All right, there's D, the normal. Now, what's next on our list to do? Oh, so we're still working with the same given s of t equals 1 over t, and we're still talking about this being feet. Oops. We're talking about this being seconds and this being feet. Okay. Next question, part E says, what does this represent in the context of our problem? And this refers to the limit as t heads to 2 of s of t minus s of 2 over t minus 2. What does that represent in the context of the problem? This is going to be the way that you probably experience limit definitions of the derivative on the AP exam. So we really need to think about what these things represent. So what is that? Well, it's a slope, but it's the limit of the slope. So if it were just the slope, we would say average rate of change, but since it's the limit of the slope, we want instantaneous rate of change. On which function? S. At what point? 2. So this is s prime of 2 or v of 2. So this represents the velocity at t equals 2 in feet per second. Okay, so another thing about the AP exam, if you just say it represents velocity, you're not getting the points because you're not being specific enough. It's the velocity at a certain point. The velocity has certain units. So don't forget to highlight those if you know those. Okay. Next, F. Find the slope of f of x equals x squared plus 1 at x equals 2. Okay, so what can we do then? Let me see. Well, I'm looking for slope at a point. Which limit definition of the derivative to use? F prime of 2 equals the limit as h heads to 0 of f of x minus f of 2 over x minus 2. So here's my f of x, and this is a previous problem. Here's my f of x, so we're going to have the limit as h heads to 0 of x squared plus 1 minus, what's f of 2? 2 squared is 4, 4 plus 1 is 5, over x minus 2. So if I tidy up the top, I get x squared minus 4 over x minus 2. And now we see that f prime of 2 is going to be the limit as h heads to 0 of, no, I've combined two different ones, I'm sorry. X approaches to, and over here, x approaches 2. I really did want to use the other limit definition of the derivative, so maybe I'll come back and do it again. So this is a difference of squares, and it factors as x minus 2, x plus 2, over x minus 2. These cancel. I did it again. X approaches 2. Now I can plug my 2 in and get 2 plus 2, or 4. So the slope on f at 2 is 4. You know, write a sentence. Writing a sentence is good for you. You should write sentences. All right. Let's do one of those other limit definitions of the derivative. So we know our f of x is x squared plus 1, and we want f prime of 2. So f prime of 2 can be the limit, again, it's h heads to 0, of f of 2 plus h minus f of 2 all over h. Phew, that's the one I wanted. So what can we do here? Well, f of 2 means I plug a 2 in there. F of 2 plus h means I plug a 2 plus h in there. So what is f of 2 plus h? Well, it's 2 plus h squared plus 1. Or 4 plus 4h plus h squared plus 1, which is 5 plus 4h plus h squared. And f of 2 is just plugging in 2, and so we get 5. So now we can say f prime of 2 is the limit as h heads to 0 of f of 2, which is this stuff, 5 plus 4h plus h squared minus f of 2 all over h. And so f prime of 2 is going to be the limit as h heads to 0 of, oh look, these cancel. So, oh, and I can take out an h. 4 plus h all over h. These can cancel. Now I can do direct substitution. And when I do, I get f prime of 2 equals 4 plus 0, or 4. So the slope on f at 2 is 4. Excellent. What's next? How about the same f of x squared plus 1, but this time you write the tangent to f at x equals 2. Why don't you pause the video and make sure you're comfortable doing that. Okay, so in order to write the equation of the tangent line, I need a point, which in this case would be f of 2, which is 2 squared plus 1, 5. I also need a slope, which is f prime of 2, and we just found f prime of 2 to be 4. But now that I have a point and a slope, I can write the equation of the tangent line. Y minus 5 equals 4, x minus 2. There's our point, there's our slope, I love point, slope, point. Next question says, write the equation of the normal. So how does this equation change if I want the normal instead of the tangent? The point is still going to be the same, but what happens to the slope? Well, since the normal is perpendicular to the tangent, I need the opposite reciprocal slope, and so y minus 5 equals negative 1 over 4. X minus 2 is the equation of the normal. I'm using the opposite reciprocal slope, but the same point. All right, nice. Well, I think that's pretty good. I have just a couple more problems for us to look at. What's the difference between average rate of change and instantaneous rate of change? And second question, how do you find each? Okay, well, we know that the average rate of change is the slope of the secant on A to B on f of x. Okay, it's the average rate of change is just that slope of the secant. So f of b minus f of a over b minus a. But if we want instantaneous rate of change, instantaneous rate of change is going to be f prime at a point. So we have to use one of our limit definitions of the derivative. The limit as x heads to 2 a of f of x minus f of a over x minus a. So instantaneous rate of change is slope at a point. This is the slope of the tangent, which only touches the curve in one place, as opposed to the secant, which touches the curve in two places. Okay. Please evaluate this limit. You should be able to do this without a calculator. These are from section 2.1 if you want some more practice with them. The limit is x heads to 0 of sine x over 4x squared minus 5x. Okay, so if I plug a 0 in and do direct substitution, I end up with 0 over 0. So, yeah, I gotta do something here. So, pause the video, give it a try, come back if you need help or want to check your answer. So I remember that the limit as x heads to 0 of sine x over x equals 1. And so I really want to sort of turn this into something that has this in it. So the limit as x heads to 0, sine x over, let's factor out an x here, times 4x squared, 4x minus 5. So I can see that x over sine x, but I think I want to do a limit as x heads to 0 of sine x over x times 1 over 4x minus 5. Right? I'm splitting this up into two fractions. In fact, I could even split it into two limits, one being the sine of x over x times the limit as x heads to 0 of 1 over 4x minus 5. So we know this is 1, and what about this? When I plug a 0 in here, that goes away, and I have negative 1/5. So 1 times negative 1/5 is negative 1/5. That's how I evaluate that. I need to know, I need to remember this, I need to use this, and that informs me or suggests to me how I should manipulate this by factoring out that x on the bottom to get the sine x over x that I'm looking for. All right, tell me the three-part definition of continuity at a point x equals a. Okay, pause the video, give that a try. So here's what I know. 1, f of a must exist. I know the limit as x approaches a of f of x must exist. And remember, for the limit to exist, that implies that the limit as x approaches a from the positive side equals the limit as x approaches a from the negative side. All right. So, third point, 1, f of a has to equal the limit as x approaches a of f of x. These can both exist but not be equal to each other, and therefore we wouldn't be continuous. Continuous requires these two values to be equal to each other. So that was our three-part definition of continuity at a point x equals a. Now what I would like is the three-part definition for continuity on a closed interval a to b. So why don't you pause that video and give that one a try. All right, so welcome back. I like to think you had that f must be continuous on a to b, and we'll do that by observation. Okay, what else do we need to know? Well, this is a closed interval, and so we have to say something about the endpoints. So I'm going to say that f of a must equal the limit as x approaches a from which side? Well, a is this endpoint, so I'm coming from the positive side of f of x. And I also need, for the right endpoint, because this was the left endpoint, we need f of b equals the limit as x approaches b. From which side? B is this endpoint, we're coming from this way, so we're coming from the negative of f of x. Okay? So there's our three-part definition of continuity on closed interval. Next, how about discontinuities? Explain or find the discontinuities in each case. First case, absolute x over x. So, do we have any points of discontinuity? I would say yes. There's a point of discontinuity at x equals 0. Well, what kind of discontinuity do we have? Is it a vertical asymptote? Well, if I plug a 0 in, I've got 0 over 0, and that's an indeterminate form. Sometimes it's infinity or negative infinity, so it could be the location of an asymptote, but in this case, it isn't, because when I cancel these out, I get 1 or negative 1 at x equals 0. In other words, there's a hole on the graph. And so I should think about this graph. There's negative 1, there's positive 1. So as I put in positive numbers, I get positive 1. As I put in negative numbers, this is negative, this is positive. A positive divided by negative will be negative. So there's my graph. So yeah, definitely not continuous at x equals 0. And I've got two reasons. I've got f of 0 does not exist, and I see this jump discontinuity, which means the limit as x approaches 0 from the positive side does not equal the limit as x approaches 0 from the negative side. Okay? So we have the point doesn't exist and the limit doesn't exist. Two really important things for continuity. How about this one? X squared minus x minus 6 over x squared minus 4. Determine any, please determine any discontinuities for this function. Okay, pause the video, give it a try. So I notice that the top is factorable as x minus 3, x plus 2, and I notice that the bottom is factorable as x minus 2x plus 2. So these cancel, which means I have a hole at x equals negative 2. Now, a hole is, so y of negative 2 does not exist. I need that point to exist for continuity. The point doesn't exist there. But that's not the only discontinuity, is it? What about that one? Well, that's an infinite discontinuity because it's a vertical asymptote at x equals 2. All right. Last thing I want for you to do is to, new rules, find f prime negative 1 given f of x equals 3x squared plus 2x. All right, pause the video and find f prime of negative 1. Well, welcome back. So we know that we're looking for the derivative of f at a point. I'm going to use f prime of x is the limit as h heads to 0 of f of x plus h minus f of x all over h. And in order to do that, I know what f of x is, but I need to find f of x plus h. And that means I have to take x plus h and plug it into both of these x's. So then f prime of x in our problem is the limit as h heads to 0 of 3x squared plus 6xh plus 3h squared plus 2x plus 2h, gotta distribute, minus, and what are we subtracting? All of f of x. So all this has to be subtracted, which means I have to have a negative there. 3x squared minus 2x all over h. Alright, so any canceling we can do? Well, this minus 2x and this plus 2x, this plus 3x squared, and this minus 3x squared. Notice how that's our f of x, and again, f of x should always completely cancel. So now I've got f prime of x equals the limit as h heads to 0 of 6xh plus 3h squared plus 2h over h. I can pull an h out of each of those terms. 6x plus 3h plus 2 over h allows me to cancel that. Now I can plug in my 0 for h and get that f prime of x is equal to 6x plus 2. Now what did I want? I wanted f prime of negative 1. So now that I know what f prime of x is, f prime of negative 1 is just going to be 6 times negative 1 plus 2, which is negative 4. All right, so let's move on to the next video because we've started reviewing for the test. Oh, by the way, tonight's homework is going to feature two things. It's going to feature some opportunities for you to determine f prime of 3 in some different cases, but also I've got some limit definitions of the derivative here, and I pointed out mistakes and missed opportunities. And so I'd like you to go through these and find what their mistakes were, but also the missed opportunity, like what was it that they should have noticed so that they then didn't make a mistake. All right, that'll be in assignment 33A. Can't wait to see you. Have a great day, everyone.